Two pipes A and B together fill a cistern in 4 hours. Had they been opened separately, then B would have taken 6 hours more than A to fill the cistern. How much time will be taken by A to fill the cistern separately? Well, let us assume that the time taken to fill the tank completely by A is X hours. So it is given that B takes 6 hours more than A to fill the system. So B will be X plus 6 hours. Now we have been given that two pipes A and B together can fill a cistern in 4 hours. So we can calculate the amount of cistern filled by both A and B in 1 hour. It is equal to the part filled by A in 1 hour, and that's 1 by X, plus the part filled by B in 1 hour, and that's 1 by X plus 6. And this is equal to, we have been given that together they fill the cistern in 4 hours. So in 1 hour they will fill 1/4 of the cistern. So you have an equation here. Let us see what the equation is. So you have X plus 6 plus X divided by X square plus 6X equals to 1 by 4. So this is X square minus 2X minus 24 is equals to 0 when you solve it. And this is a quadratic equation. When you solve it, you'll get two roots. One root of X will be equal to 6 and another root of X will be equals to minus 4. So you can always ignore the negative values. You can take the positive values. So X is equal to 6. And what is X? Well, X is the time taken by A to fill the tank completely. So it is 6 hours. And that's what is asked. How much time will be taken by A to fill the cistern separately? So that is 6 hours. So option C is the correct answer. A tank is filled in 5 hours by 3 pipes A, B and C. The pipe C is twice as fast as B and B is twice as fast as A. How much time will pipe A alone take to fill the tank? Now let us assume that the time taken to fill the tank completely by A is X hours. Now it is given that B is twice as fast as A. This means that B will take half the time to complete the work. That is, B will take half the time to fill the tank completely. So time taken by B will be X by 2. And it is also given that pipe C is twice as fast as B. Again, it means that the pipe C will take half the time taken by B. And time taken by B is X by 2. Half of that will be X by 4 hours. Okay, now it is given that the tank is filled in 5 hours by 3 pipes A, B and C. So let us calculate how much of the tank is filled in 1 hour when these 3 pipes are on, A, B and C. Well, it is given that the tank is filled in 5 hours by all of these 3 pipes. So it is equal to 1 by 5. But this is also equal to the amount of tank filled in by A in 1 hour plus the amount of tank filled in by B in 1 hour and the amount of tank filled in by C in 1 hour. So this will be equals to the amount of tank filled in by A in 1 hour will be equals to 1 by X plus by B will be 1 by X by 2, that will be 2 by X, plus amount filled in by C in 1 hour will be 1 by X by 4, that will be 4 by X. So you have 1 by 5 is equals to, in the denominator you have X, in the numerator you have 1 plus 2 plus 4. So this is equals to 7 by X. So therefore X is equals to 5 times 7, and that's 35 hours. So 35 hours is the time taken by A alone to fill the tank. So option C is the correct answer. A large tanker can be filled by 2 pipes A and B in 60 minutes and 40 minutes respectively. How many minutes will it take to fill the tanker from empty states if B is used for half the time and A and B fill it together for the other half? Well, let us first calculate the part filled by B in 1 minute, and it is equals to 1 by 40 because B fills the tank in 40 minutes, so part filled by B in 1 minute will be equals to 1 by 40. Right. Now let us calculate the part filled by both A and B in 1 minute. It will be equals to the part filled by A in 1 minute plus the part filled by B in 1 minute, and that's 1 by 60 plus 1 by 40, and that is equal to, you'll get 1 by 24. Now let the total time to fill the tank from empty state to full be x minutes. Right. Now it is given that B is used for half the time. So the part filled in half the time by B will be equals to half of the time is x by 2 times the part filled in 1 minute by B. So times 1 by 40. Plus the other half is filled by A and B together. So plus again half of the time is x by 2 times you have the part filled in 1 minute by A and B is 1 by 24. And that is equals to 1 because when you add both the parts you have a full tank, and that's 1. So now you can solve it. You have x by 80 plus you have x by 48 is equals to 1. When you'll solve this equation, you'll get the value of x as 30. So 30 minutes is the total time taken to fill the tank. Option D is the correct answer. Two pipes can fill a tank in 20 and 24 minutes respectively, and a waste pipe can empty 3 gallons per minute. All the 3 pipes working together can fill the tank in 15 minutes. What is the capacity of the tank? We can calculate the part emptied by the waste pipe in 1 minute. Well, how do you calculate that? We will take the amount of tank filled in by all of the 3 pipes. That means filled in by 2 pipes and emptied by the waste pipe in 1 minute. Well, all the 3 pipes working together can fill the tank in 15 minutes. In 1 minute, the amount of tank filled is 1 by 15. And we will subtract the amount of tank filled by the 2 pipes working together in 1 minute. So minus 1 by 20 plus 1 by 24. And this will give you the part emptied by the waste pipe in 1 minute. So that's equals to 1 by 15 minus 11 by 120, and that will give you minus 1 by 40. Don't worry about the minus sign. It shows that the tank is getting emptied. Now it is also given that the waste pipe can empty 3 gallons per minute, and from our calculations the waste pipe empties 1 by 40 of the total capacity of the tank. It means that 1 by 40 is equivalent to 3 gallons. Right. So what is asked is, what is the capacity of the tank? So the full capacity of the tank will be considered as 1. So how much gallons do they correspond to? So cross multiply and equate, we get x by 40 is equals to 3. So x is equals to 3 times 40, and that is 120 gallons. So our answer is option C. 120 gallons is the capacity of the tank.